So let's look at some graphing, and on these questions it wants you to describe how you can graph this function knowing the basic function. Alright, so first off, you need to make sure you know what these basic functions look like. This would be x squared, this would be the square root of x, this would be the basic function here, would be x squared again. So then I'm looking on page 137 here. Then you've got these rules about how the graph can be translated vertically, horizontally, reflected, and then stretched or shrunk. All right. Most people get the vertical translations, the horizontal translations, and the reflections. It's the shrinking and stretching that's the issue. So here's the rule. If you have a value in front of your basic function and you're multiplying by that value, you're going to either have a vertical stretch or shrink. It's going to be vertical, and it's either going to be a stretch or a shrink. Now, which one is it? Well, if the value is bigger than 1, we don't care about it being negative. That's why there's absolute value symbols. But if it's bigger than 1, we're going to stretch. Okay. If it's in between 0 and 1, basically a fraction that's in between 0 and 1, it's going to be a vertical shrink. All right, we're going to shrink vertically. Now, if you multiply and the multiplication occurs on the actual x in the function, then you're going to do a horizontal stretch or shrink. And if it is above 1, it's going to be a shrink. If it is between 0 and 1, it's going to be a stretch. All right. So what you need to do is make sure you understand, keep these things straight. Make sure you memorize these right here. So how would that look? Well, for instance, let's base this off of what if your original function is, let's say, the square root of x. Okay, if I put a 2 in front of that function, square root of x, then since it's on the front, since it's on the outside of the original function, it's going to be this vertical stretching. And since that value is bigger than 1, it's going to be vertical stretching. Okay, it's going to be vertical stretching. Now, what would make it a vertical shrink? Well, it has to be between 0 and 1. So instead of a 2, let's say it was a half. That's going to make it a vertical shrink. Okay, now, so how is that different than a horizontal? Well, the 2 would actually be on the x. What I mean by that is it would be square root and it'd be 2x. Or it'd be a square root and a 1/2 x. See, the difference is the value you multiply by is actually on the x. Now, if it is bigger than 1, in this case, it's going to be a horizontal shrink. If it's between 0 and 1, if it's between 0 and 1, which is this case, it's going to be a horizontal stretch. So there's your different methods for horizontal stretching and shrinking. So I'm going to write that out. This is right here was a vertical. That's a VST. And this right here was a vertical shrink, a VSH. Or VHS, I don't know, VSH. This right here, this 2 was bigger than 1 here. So that's going to be a horizontal shrink. HSH, and this one was a stretch because it was between 0 and 1, a horizontal stretch. Now, I don't know how you can memorize that however you want to, but this little table is going to help me out, I think, a lot better than me going back and looking at these rules over and over again. So, if I'm going to graph number 15, describe how to graph it. Well, we're based off the square root of x, and the function now is g of x equals negative 1/5 square root of x. Well, this is the original, right? So I'm multiplying by 1/5. I don't care about the negative. The negative is a reflection. Basically, the negatives are, if it's on the outside like this with this number, it's an x-axis reflection. So that's an x-axis reflection. And then this guy, remember what he does? He does a vertical shrink. And if we're going to graph this, this might be the original. So we would flip it over the x-axis and then shrink it vertically. So it'd be like this. It would be shrunk by a factor of 1/5. And I graphed it here on my graphing calculator. If you wonder how you would graph that, well, I did have it graphed. The calculator just died. Oh, there it is. Okay. This is how I'd graph it on my graphing calculator, and it would look like this. You lose your curvature, but yeah, it's been shrunk vertically. Okay, so what about number 16? Okay, the original function is the absolute value function. Now check this out. I like to rewrite the function here. The 1/2 is in front of that x. So what's that going to do? Remember what happens if there's a 1/2? If there's something in front of it, it's a vertical. And it's a fraction. It's going to be a vertical shrink. That's what that does. This is just the original function. Now what's the -7 on the outside do? If it's -7 on the outside, it's not inside there. It's going to be a vertical shift, up or down. Since it's minus, it's down. So if I was going to graph that, here would be my original. Let's remember the absolute value is a v. I'm going to vertically shrink it and then move it down 7 spots. So if I want to graph that, let's delete that off. Clear. We're going to put the 1/2 in. I always like to put my fractions in parentheses if you got these old school calculators. Oops. And then remember to find the absolute value, hit the math button. Mine's right there. Or denom, it's ABS right there. Put my x in and close it up. That's the 1/2. So I've graphed this so far. -7. Hit the minus key, not the negative, but the minus key, -7. And then graph that bad boy. Yeah, see how it's been flattened out some. See how it's been flattened out, and I didn't flatten mine out enough, and it went down 7. Okay, so what's the basic function here? So we've got g of x equals x plus 5 squared plus 3. So the basic function here, that squared tells me that the basic function is x squared. Now the plus 5 and the plus 3 is what moves it around. Is what moves this around. So since this is on the outside, like before, like that 7 was up and down, since this is on the outside, that's going to be, and it's plus, that's going to be up 3. And this is on the inside, so that's going to be horizontal movement, left or right. And you would think you go right, but it's actually backwards when it's inside here. It's to the left 5. If we wanted to graph that, remember the parabola would look like such. And we move it up 3 and to the left 5. There'd be the new vertex. And they're supposed to look exactly the same, but you know, I can't draw very well. Excuse me. All right, number 18. So here's your original. And what's this based off of? Well, the square root is the operation here. The -4 is not really the original basic function. It's the operation of square root that is the original function. Okay, and since that -4 is on the inside, it's not on the outside. If it was -4 out here, it'd be vertical. But since it's underneath here, then this is left and right movement, horizontal. And since it's negative, we go to the right 4. So here's the original, and we're going to move that to the right 4 units. 1, 2, 3, 4. Okay. And number 19, a new piece of paper. Describe how the graph of g of x equals -1/2 x plus 3 squared. Now the basic graph, f of x, would have been x squared. All right, see the power of 2, that's your basic graph then. So what does all this other stuff do? Well, remember the 1/2, it's out front. If it's out front, it's a vertical shrink. The minus out here is going to be an x-axis reflection. Oh, by the way, what would make it a y-axis? That negative would actually be on the x. That negative would be on the x. It would be right here next to the x. That's how you do a y-axis reflection. The +3, since it's inside the parentheses, it's left and right movement. It's horizontal movement. And since it's +3, it's to the left. It's kind of backwards of what you would think it would be. So if this is the original parabola, that's horrible. That's horrible. I can't let that go. All right, that looks better. That's the original. We want to move it to the left 3. All right. Then we're going to do a vertical shrink, which basically makes it wider. And then, so it would look like this. And then we're going to reflect it over the x-axis, so it would look like that. That's how that should be how it looks. Let's double check to make sure. Be negative 1 divided by 2 parentheses x +3 parentheses squared graph. Yeah, see, it's a lot wider. The original would have been x squared. Yeah, the original is skinnier, basically. Okay, so let's split this up. In the next, we'll do 20. The rest of them in